Redesign of FSAE components with carbon fiber fabrication.
Hello everyone, we're with the Formula Society of Automotive Engineers, and our project is an ergonomic redesign of components with carbon fiber fabrication. My name is Sunny Downs.
I'm Martha Gonzalez.
My name is Thomas Aaron.
I'm Natalie Torres.
And I'm Colby Phelps.
And our advisor is Dr. Lee Smith.
So our objective is to optimize component design for driver interfaces and reduce overall mass.
So we had two primary motivations with our designs, one being increased driver safety and driver comfort.
In terms of our technical approach, we designed in SolidWorks, ran FAE and CFD to refine the product.
This is our design and testing phase Gantt chart from last semester. This is where most of our research was done, and the component design along with our test pieces of carbon fiber that we made. And this is our fabrication phase Gantt chart, where all of our really hard work went into making all of these components.
So first designs that we'll get into is our steering and shifting components.
Here's some design specifications for the steering system. We want a positive steering stop, and we don't want it to be, we want free play to be less than 7 degrees. For the steering wheel, we want it to have a quick disconnect and not go over the top roll loop. And for steering linkages, we want tension and compression. So for these designs, the to your left are going to be the preliminary designs. They're kind of simple and have a lot of material. And to the right, you'll see the final designs. We were actually able to make a 3D printed prototype for the driver to test out. We had some inputs that the steering wheel was a little too small because the drivers had larger hands, so we took their inputs into the final design on the bottom right.
And to your left, you'll see our shifting linkages, which are made of three separate 3/8 inch carbon fiber tubes. That 3/8 inch is the inner diameter, with aluminum inserts for the fitment of the hardware. These differ from last year's, as last year's were made out of T6, 60, 61 aluminum. Right here you'll see our new steering column. This one is made out of a 1/2 inch inner diameter carbon fiber tube. This one differs from last year's, as last year's only had one universal joint, while this one has two helicopter joints, and this helps with the variable torque that is seen from the steering wheel. And then down here you'll see our water jetted 1/2 inch plate of carbon fiber. This is going to be our cost breakdown. We did have some material get provided to us from Mean Green Racing, which is not seen here, but for components that we did have to buy with our budget, our total cost came out to be $548.
Okay, moving on to our pedal box. This is the product design specifications that I'll talk more about in just a moment. So the focus here was to reduce deflection on the applied braking force to improve driver input feel while maintaining a low weight. So to the left, you can see our first design ideas, and to the right are our final brake pedal and pedal box designs. You can see in the bottom right picture the throttle, and I'll also show you here. The throttle actuation linkage was redesigned to ensure that the throttle will open at a constant rate with the travel of the throttle pedal itself. For the analysis, we applied a 2,000 Newton force on the brake pedal in accordance with the FSAE rules. We achieved a minimum factor of safety of 1.1. I would like to note that that 2,000 Newton force is double the expected maximum force that will ever be applied to the brake pedal. So a factor of safety of 1.1 is acceptable in this case. For fabrication, with fabrication constraints and the caseload applied on the pedal box, composite materials were a poor choice for this component, so we decided to water jet the part out of 6061 aluminum. And then all pocketing and holes were created in-house using a mill. Here's the cost breakdown, resulting in about a $400 part. I would also like to note, before we go into the closeout panels and bodywork section, that our initial plan was to use FSAE's sponsorship with Peterbilt to CNC our foam bucks for our molds for our carbon fiber layup. However, due to unforeseen circumstances, we had to make the last minute decision to make the mold bucks by hand, which was a very strenuous process. It took a lot of time and effort from the team in just the last couple of weeks, but we are really proud of what we produced as our final outcome. So.
Here you're gonna see our testing piece from our first semester. This is the technique that we decided to go with. This is vacuum bagging resin infusion technique. From here, you will, on the buck, you would like to ideally make a fiberglass mold and then lay up inside that mold and then use the vacuum bagging. Unfortunately, due to our time constraints, we decided to lay up directly onto the mold, in return destroying the bucks that we had handmade. Here are product specifications for our floor closeout and bodywork. For our closeout specifically, we're gonna want no gaps to exceed more than 3 millimeters. And then for our bodywork, any forward and leading edges has to be minimum radii of 38 millimeters.
To your left, you'll see the floor closeout. It's based off of our previous design. We changed, obviously, to carbon fiber from aluminum, saving weight. We also changed the raised sides to be more angular, to save material.
So on the right here, we have our nose cone designs. At the top is our, what we were originally gonna go with, which is one complete piece, but after considerations, we thought it would be easier and more efficient to have two separate pieces, which is what you see at the bottom here, since we are trying to access our pedal box quicker, and this is our top panel there.
For fabrication, we just took the side view and wanted that out.
So, due to a Z-axis restriction on the water jet, we had to individually make these foam pieces as you see here and glue them together and sand them down by hand ourselves. And at the bottom here, you can see our carbon fiber layup and our vacuum bagging with the resin going through. So here's an analysis between the two different nose cones. The SA team previously had a cone buck already made, which is what you see at the right here. And after running analysis at about 60 miles an hour, the previous cone was a little better and lower drag. And this is just showing the process of the different layups we have to do for the vacuum bagging.
So this is our side pod design and analysis. As you see on the top left there, we actually went through a couple different iterations. The top left iteration was our final iteration at the end of last semester, but due to some input from our sponsor from Peterbilt, we actually had some really good input in terms of the draft angles that were going to be applied to the mold. In terms of the draft angles, the draft angles did not align properly, and it was going to make the molds pretty much impossible to separate, if either really difficult or impossible to separate. So based on their input, we decided to redesign the side pods. So at the bottom left part, you can see the redone molds for the side pods, and then we ran some CFD on the new side pods. We ran some CFD on the old side pods as well. That's not shown here, but the CFD for the new side pods, probably because they're smaller, we actually got a lower drag. We had drag reduction based on the new design. So in terms of fabrication of the side pods, pretty much just like the nose cone and floor layout, we had to water jet out each individual layer for the molds, and then glue them together and then sand them to the size that we wanted. And this was probably the most difficult part to do because they had very specific shape to it, and it kind of rounded off. And then as you see in the middle there, that was our fabrication process for the molds. We used a vacuum seal and then ran resin through it, and then the resin, after the resin hardened after 36 hours, you can see our final product being separated from the molds on the bottom right there.
Alright, and this is gonna be our cost breakdown for each one of these components. We were very grateful once again for Mean Green Racing having these, this material already on hand for us to be able to utilize. Our floor closeout came out to be a total of $348 roughly. Our nose cone came out to be roughly about $415, and then the hood $275, and then our side pods came out to be $563. Our total project cost came out to be around $2,040 with all the fabrication that we did. And here's our references.
Thank you. Any questions?
How much composite work have you done before?
This was pretty much our first
Yeah.
time.
Our
Last
first-
semester
What
we
was your,
did some
what was your
test.
biggest, obstacle to overcome? Learning about composites.
I'm sorry, we repeat the.
Biggest obstacle you had to overcome learning about composites?
Oh, definitely the mold making process.
Yeah, the draft angles were pretty difficult to get a mental hold of in terms of, specifically for me, in terms of the design of the side pods. Like I said, the input from Peterbilt was invaluable in terms of the tips that we used.
And we were definitely dependent on having all of our molds CNC machined for us. And we found out on April 3rd that was not going to happen. So the last 3 weeks we have lived here. Yes, ma'am, Dr. Knight?
I'm sorry. Oh, you mentioned that you use CFD. I just wanted to know what software you were using.
Well, we use SolidWorks for the CFD analysis. And personally, this is the first time I've ever had to use CFD analysis, so it was a learning process throughout the entire process. So it kind of helped that we had multiple different iterations, so we had multiple different ways to learn the software. So yeah.
Did you guys try to implement any other material except carbon fiber?
No, we did not. We knew that we wanted to use carbon fiber from the start because carbon fiber is stronger than aluminum and steel, and it is also much lighter weight. It is about half of the weight of aluminum.
Is that stronger than the nylon and carbon fiber together as a compound?
I'm not sure about that. I would have to do some research. We already had all of our carbon fiber materials, so that's what we went with.
I have just a comment on the need, we are the pioneers using carbon fiber here, and then you establish the need to have in here more dedicated equipment, like for example, CNC routers for this specialized materials. We will have take that into account for our next round of investments in the future.
There's also a paint booth.
Absolutely.
Thanks. Any other questions?
You guys had 4 items, right?
Oh, we
No,
had in total 7?
Yeah, so we had our shifting linkages, our steering column, the pedal box, the steering wheel, the floor closeout, and the floor hood, and the nose cone.
So how did you guys divide the workload?
We did it all each other.
We pretty much all did everything together. The design was split up between us, and then the fabrication we